Hi everyone, welcome back to the channel. So today we are kicking off a two-part series where we explore the efficiency of screw conveyors. In this first video, I'll walk you through how to model the screw conveyor in Solidworks step by step. I use Solidworks, but if you are using any other CAD modeling software, that's okay. Then in the next video, we will simulate like bulk material flow through it using EDEM to analyze the efficiency. So let's get into the geometry. So what is a screw conveyor? Well, I'm going to give you a basic definition of a screw conveyor. Right? So a screw conveyor is a mechanical system used to move granular or semi-solid materials horizontally or at a slight incline. It's widely used in industries like agriculture, food processing, mining. Okay, so the basic components: the helical screw, also called the flight, the central shaft, an outer casing or tube, then the input and output ports. Okay, so first we are going to model the screw conveyor part, then we will later model the outer casing, right? So I'm currently on the Solidworks homepage, right? So let's click that. Okay, so the for the dimensions, I've gotten the dimensions from this website that manufactures screw conveyors, right? So for the screw diameter, it was like for the imperial units, it was 6 inches, then standard length 10 feet, shaft diameter 1.5 inches. So I have converted to metric and rounded them. So for the screw diameter is going to be 150. Then the standard length is going to be 3050 millimeters. Then for the shaft diameter 40 outer diameter. So let's model this shape. Okay, we begin with the shaft diameter. Let's put okay, let's put 40. Let's make the shaft hollow. So let's put 38. Right. Let's extrude 3050. Okay, it's quite long. So now let's go on to model the flightings. So as you know, we must leave the space for what to be attached to the bearings, right? So let's first create a plane which is parallel to this first plane at offset. Let's make it decided to make it 50 millimeters, right? Okay, let's sketch on this plane. Okay, so the screw diameter is 150, right? This 150 millimeters. Wow, this is quite huge. Okay, go on curves, helix spiral, reverse direction. Where is it going? So as you can see, this is clockwise. Okay, then for the pitch, let me look it up real quick what they were using for the pitch. What about the pitch? Where's the pitch? Okay, let's put a pitch of 150 millimeters. Right? 5. Okay, there it is. It came out nicely, right? Then we want to sketch again on this plane we created. So let's select sketch. Okay. Let's from here to here. No man, no. Okay. Okay. There it is. So now we use the swept surface command. This one. Select. Okay. There we have it. Sorry. Okay, so now we are left with thickening this surface feature. Thicken. Select it. 10 is too much. There we have our screw conveyor. Come on, isn't it nice? Okay, so in this video we are done with the screw conveyor. Let's move to the casing. So for the outer casing, we are going to leave a distance of 1 millimeter on all the ends. So let's jump right into it. Sketch. Okay. Doesn't matter which pen is selected. So right. Smart dimension 154. Right. This one 40,000. Okay. So we now want to leave the entrance for the bearings with the shaft of the screw conveyor. So okay, let's first show this. Show preview. This right. Sketch. But dimension is 150. So this has to be 70 in order to leave a distance of 1. So we'll make it okay. We'll just put 78. Right. So something was wrong. It's actually 40 millimeters. What about the dimension for you? Okay. This is more like it. Wait, let's close the upper layer. sketch on this. Convert entities. Okay. Okay, let's thicken this. Chain is too much. Let's put 2. Okay. So now let's put the entrances. Entrance and the exit. Suppose here. Should cut. That. Exit. Sketch. Okay. This. Sorry, I meant extrude cut. Okay, there we have it. Let's save this as the outer casing. Outer casing. Okay, so let's now combine the two. There we have it. Okay. So we need to first add a concentric match like this. So unlike Simscape, if you have used MATLAB, Simscape, the GUI environment, Simscape requires one to actually take note of the maths you are using, right? But for EDEM, it doesn't pay that much attention to all kind of maths, so we are using the what. Okay. So now we have to use the what. Let me pull this out. This. Use the advanced math for width. Right. Make this side. What? This side. This face and what? This face. Okay, that's it. I think I have to change the transparency of this. So the outer casing, as you can see, is fixed, right? The first part you put when creating an assembly, it will be automatically fixed, and you can confirm that by this F in parentheses, right? So let's try to see. Okay, as you can see, our screw conveyor is what? It's rotating. Okay, so we are done modeling the screw conveyor. Now we want to do the actual bulk model simulation in EDEM. Till next time, peace. Oh, let's save this to step 5. Okay, step 5. Screw conveyor. Simulation. Okay, thank you.